Hey everyone, welcome back to Engineer to AI. I'm a software engineer learning AI, and today we are diving into one of the most powerful concepts in AI right now. It's called RAG. RAG is abbreviated as Retrieval Augmented Generation. Now, I know that sounds very technical and scary, but trust me, by the end of this video, you will understand RAG completely. And you will see exactly why every serious AI application uses it. So, now just we come to an agenda. First, we will understand the problem that RAG solves. Because before you learn the solution, you need to feel the pain. Then we will understand what RAG actually is, how it works step by step, what vector databases and embeddings are, and how RAG compares to fine tuning, and finally, how to implement RAG using Spring AI in Java. So let's begin. Let's start with the problem. Imagine you hire the smartest person in the world. They have read every book, every article, every website ever published up until January 2024. Now you ask them, what was our company's revenue last quarter? They have no idea because this information was never in any book they read. You ask them, summarize this PDF I just uploaded. Again, no idea. They have never seen it. That's exactly the problem with ChatGPT and every other LLMs. They know everything about the world, but nothing about your world, your company docs, your internal data, your recent files. They simply don't know any of it. So, what do we do? We could retain the entire model with our data, but that costs millions of dollars and takes months. Or we could use RAG, and that's exactly what RAG solves. Now, what is RAG? RAG stands for Retrieval Augmented Generation. Let me break every word down simply. Retrieval means find relevant information from our documents. Augmented means we add that information to the question before asking AI. And generation means AI generates an answer using that extra context. Let me give you a real world analogy. Think about an open book exam. In a closed book exam, you can only answer from memory. That's normal ChatGPT. But in an open book exam, you bring your textbooks, notes, and reference materials. You look up the relevant pages and answer based on what's in front of you. That is RAG. RAG gives the AI an open book to refer to, and that book is your documents. Now, how RAG works. Let me show you exactly how RAG works behind the scenes step by step. So now step 1, you see here your documents. You have PDFs, Word docs, websites, database records. Basically any text data you want AI to know about. Let's say it's your company's employee handbook. Okay. Now second one is step is chunk and embed. The system splits these documents into smaller pieces, maybe 500 words each. Then it converts each piece into a special mathematical representation called an embedding. Okay. Think of it as giving each chunk a unique GPS coordinate in a meaning space. Okay. Step 3 is vector database. So all these embeddings, these GPS coordinates are stored in a special database called a vector database. It's like Google Maps, but for the meaning of text. Now, step 4 is user query. Now a user asks a question. For example, how many vacation days do I get as a new employee? Now step 5, we have retrieve an answer. Then the system converts that question into an embedding too. Then it searches the vector database, finds the top 3 to 5 most similar chunks from your handbook and sends both the question and those chunks to ChatGPT. So ChatGPT now reads those chunks and says, based on the employee handbook, new employees get 15 vacation days per year. That is a RAG. The AI didn't know this before, but now it does because we retrieved and injected the right context. Now, next is embeddings. You might be wondering what exactly is an embedding. Let me explain with simple example. Imagine I say the word king and I say the word queen. These two words are different, but their meaning is very similar. They are both royalty. And embedding converts text into a list of numbers, maybe 1500 numbers that captures the meaning of that text. So king might become something like 0,82, 1.5, 0.94, and the queen might become an array of 0.81, 0.16, 0.93, very close numbers. Now bicycle would be something completely different, like an array of 0.12, 0.88, 0.05. Far away numbers. In simple terms, simpler meaning, similar numbers is equals to close together in space. Real world example. If you ask what is the leave policy, the system finds chunks about vacation days, sick leave, public holidays, because their embeddings are all close together in a meaning space. Pretty cool, right? Now we come to the vector DB. What is it? Now let's talk about vector database where all these embeddings are stored. Think of a normal database like a library with a traditional card catalog. Now, you can search by exact title, by author name, by date. But vector database is like a magical library where you can search by meaning. You walk in and say, I want books about timings that feel like summer and joy. And it finds exactly those books even if none of them contains those exact words. That semantic search, and it's what make RAG so powerful. Now there are several popular vector databases you should know about. Pinecone is a fully managed in the cloud, great for production apps. PG Vector is a Postgres extension. So if you already have a Postgres database, you can add vector search to it. This is very popular for Spring Boot apps. Viviate is open source and very flexible. ChromaDB is perfect for local development and testing. And you know what is the great news? Spring AI supports all of these. You just swap one dependency and your code stays the same. Now we'll see the comparison between RAG and fine tuning. A very common question I get is, why not just fine tune the model? Why go through all this RAG complexity? Let me explain with a real world example. Imagine you want your AI to know about your company's 500-page internal policy document. Option 1, fine tuning. You take that document format it as training data, send it to the OpenAI or train it yourself. This costs, friends, thousands of dollars. Takes days or weeks. And when the policy changes next month, you have to do it all over again. This is the option 1. Now come to the option 2. That is RAG. You load the PDF into your vector database. It hardly takes 5 minutes. Query it in real time. When the policy updates, just reload the PDF and you are done. So when you should use RAG? When your data changes frequently. When you need real-time information. When you care about privacy. When you need to save money. Now, when should you use the fine tuning? Now, fine tuning can be used when you want the AI to change its personality or writing style, or when you need it to follow very specific formats consistently. If this is a requirement, then go and use fine tuning happily. For 90% of the real business use cases, RAG is the answer. Now, Spring AI, as we already have seen, integrated Spring AI into our Spring Boot. Now we will see how we can use this combination. Alright, now the exciting part for us as a Java developer, how do we actually implement RAG with this Spring AI? It's surprisingly simple. Let me walk you through these 3 steps. Step 1, add the dependencies. Just add the Spring AI OpenAI and Spring AI PG vector to your pom.xml. That's it. Spring Boot auto configures everything. Step 2, ingest your documents. You use the vector store interface. You load your PDF or text, convert it to document object and call vector store.add. Spring AI handles chunking, embedding and storing automatically. Now the step 3, query with RAG. Add this is beautiful part. You just add one line to your existing Spring AI code, a question answer advisor, and that advisor automatically retrieves relevant document chunks and injects them into every prompt. Think about that. One line of code and your AI chatbot now has access to all your documents. In the next video, I will build this live, step by step, so you can follow along and build your own RAG application. Now we can just see a real world example, use cases. Now let me show some real world applications of RAG that are being used right now. So this is enterprise knowledge bot. So this is, imagine a company with 10,000 internal documents. New employees can ask, what is the onboarding process? And get precise answers from actual company docs. No more searching through folders. Legal document analyzer. Law firms upload case files and contracts. Lawyer asks, what are the penalty clauses in this contract? And get the exact answer with the source highlighted. Medical reference assistant. Doctors can query clinical guidelines and drug interaction database in plain English. What is the standard dosage of this drug for a 60-year-old patient? That is answered instantly. For us as developers, imagine a code documentation bot. You upload your entire code base documentation and API specs. Your team asks, how do I authenticate with the payment API? And gets the exact answer from your docs. So all of these are powered by RAG, and all of them can be built with Spring AI and Java. So now here are some key takeaways. Let's quickly recap the 6 key things you learned today. 1. RAG gives AI external memory. It lets LLMs answer from your documents without any retraining. 2. RAG has 3 steps. Retrieve relevant chunks, augment the prompt with those chunks, and generate a grounded answer. Third, embeddings. Embeddings are the meaning as numbers. Similar meaning equals similar numbers equals accurate retrieval. 4. Vector database and the storage. Vector database and are the storage engine. PG Vector, Pinecone, Vivian. Spring AI supports all of them. 5. RAG beats fine tuning for most use cases. It's cheaper, faster, real time, and privacy safe. And eventually, the last is Spring AI makes RAG dead simple. One question answer advisor line, and you are done in Java. So, if you understand all 6 of this, you now know more about RAG than most developers out there. So now that's RAG, Retrieval-Augmented Generation. I tried explaining as simply as possible, and along with that I gave a real time examples where we are using. In the next video, I'm gonna show you how to build a complete RAG application using Spring AI and PG Vector from scratch. Live on screen step by step. If this video helped you to understand RAG, please like it. It genuinely helps this channel grow and let me keep making content like this. Subscribe and hit the bell so you don't miss the Spring AI RAG tutorial coming next. And yes, also drop a comment below. Tell me what kind of RAG applications you would build. I honestly read every single comment. So this is it. And we'll meet you in the next video. So goodbye and take care for now. Thank you.